is the second day of our symposium. So we are continuing from yesterday, and the first session as inauguration has been done yesterday, so there will be no inauguration. But we have with us Dr. Devashish is Executive Director, TIC, Indian Oil R&D Center. So he is our guest today. So to chair this entire session, I would like to request Professor Parthasarathi Rai to come up to the dais. Now we have also with us Professor Jana. He is from USA. Professor Jana is Associate Dean of Research, Graduate Studies, and Professor of School of Polymer Science and Polymer Engineering, College of Engineering and Polymer Science, University of Akron. So I would like to request Professor Jana to come to the dais to raise the chair. I would like to request Dr. Devashish Bhattacharya to come to the chair to place the chair. So I would like to request our students to present flower bouquet to Dr. Bhattacharya. Please. To Dr. Bhattacharya. And Professor Jana. Now, I would like to request Professor Rai to say something. Should I read something about what to say, or? So today in the morning, Dr. Bhattacharya will deliver a speech. Dr. Bhattacharya is currently Executive Director, Technology Implementation Cell at R&D Center of Indian Oil Corporation Limited. He has more than 30 years of diversified experience in developing new process technologies, refinery configuration study, technology commercialization, process performance improvement, troubleshooting, revamp, etc. in petroleum refining area. Since 2006, he has spearheaded provided a part of refining technology activity at R&D Center, leading to development and commercialization of several new technologies. From 2018 onward, he has been instrumental in developing a dedicated group which is termed as Technology Implementation Cell for faster commercialization and licensing of in-house developed technology. Mr. Bhattacharya holds BTech degree in Chemical Engineering from the Department of Chemical Engineering, University of Calcutta, and MTech from Indian Institute of Technology, Kanpur. He has also successfully completed hybrid certification program of project management conducted by Universitas 21 Global, Singapore. He has more than 75 process and technology patents granted and several technical papers in journals and conferences to his credit. He is also the recipient of 7 national and 1 international level award for development of new innovative technologies and successful commercialization. So I would like to request Professor Rai to say something.
It is the second day of the symposium. We have quite a few of our alumni who are well established, and they will be talking to you about their accomplishments, and will be reading some presentations. I would advise, particularly the students over there, to interact with our alumni over here, because they can tell many things about what direction chemical engineering is taking, what are the lines you can take, what might your prospects be, your future prospects in different organizations in India or going abroad. Those things you can discuss with these people. I would advise the students particularly to take this opportunity to utilize their contact as much as possible. I would like to request Shadman to chair this session.
Good morning to all people who are in the audience today, and I have been informed that there are quite a few attendees who are online, right? Yes, okay. So anyway, good morning to all of you, whichever part of the world that you are in. So it's my extreme pleasure today to introduce our speaker, Debashish Bhattacharya, Executive Director, Indian Oil, R&D Center in Faridabad. So Debashish and I, we overlapped for some time at RKA Anandapur, while both of us were doing chemistry. And then I came here for chemical engineering, and Debashish did also finish his BTech degree here. I went to IIT Kanpur for masters, so did Debashish. So quite a few common stream of path for us. But although you see a doctor, and he shared with me that he didn't finish PhD. So anyway, but the amount of work that he has done is equivalent to a recognition that you can give to a doctoral candidate. So before I bring Debashish to the podium, so let me, Dr. Kamila asked me to share with you some opportunities that US universities have for undergraduate students from this department. So especially the university where I teach, we have opportunities for PhD students in chemical engineering, in the School of Polymer Science and Polymer Engineering for students who did undergraduate work in chemical engineering. For this year, for fall 2023, the application deadline is January 15. All you have to do is to have good GPA. I hope that most of you have good GPA. You don't have to appear for GRE. GRE is waived because of the COVID. But you have to take a TOEFL test and score 79. And in the speaking part of the same TOEFL test, you have to score 23. So if you qualify, just drop me an email. And there are not too many journals in the US. So if you type my name, my page will come up and my email address is there. Also, you can come and see me afterwards. So without much further ado, let me invite Devashish Bhattacharya to give his talk.
Thank you, sir, for introduction. Very good morning to you all. My respected faculty members and my seniors who are present over here, dear students, ladies and gentlemen. At the outset, I would like to thank that I was given the opportunity to stand before you and make a presentation. I am really thankful for that. I wish I could come a couple of years back, but it is never, it is better late than never. Okay. Hello. Am I audible?
Hello.
Hello.
Those who are on the other side, those who are attending, please kindly put off your microphone. Kindly put off your microphone, otherwise it is hampering our program. Those who are online, please.
অসীম অনলাইনে মিউট করে দাও না সবাইকে মিউট করলে কি হবে ওই স্ক্রিন ছোট হয়ে যাবে আপনাকে তো এরকমই করতে হবে
Am I audible now? Yeah. Sorry. So once again, I thank you for this opportunity, and I look for such opportunities in the future as well. Today, my topic is changing outlook in petroleum industry in emerging scenario, because I have been working in petroleum industry. And as you have heard that I was involved passionately to develop many technologies and commercialization of them. But now I find that we have come to a crossroad where we need to look back and then strategize that what we should do in the future. So my presentation is all about that. So broadly the outlook I will be covering a brief because a lot of students are there. I thought it is appropriate to touch some basics of crude oil refining. From there, I will take you to the energy requirement in the world as well as India and how it is changing because of global warming and climate change and what is there for the petroleum industry in the future. Is it that last nail on the coffin of petroleum industry or there is something beyond that? So crude oil is essentially a combination of several kinds of hydrocarbons except olefins because olefins are not naturally available. So it has all kinds of atoms, I mean complexes, molecules, and there are certain heteroatoms like nitrogen, oxygen, sulfur, some metals. So this is a The boat slightly not coming.
continue with that.
Yeah, yeah. Okay.
Yeah. Let's continue with that.
So, crude oil comprises various types of hydrocarbons, some of the heteroatoms, some of the metals. Now, if you look at the product specifications, so there is a limitation of heteroatoms as well as metals. So, when we do the crude refining, we need to produce the products of required boiling ranges and required specs. And that requires processing of the crude oil, and that is essentially a petroleum refinery is all about. So it starts with distillation column under atmospheric pressure, and bottom of that is taken to a vacuum column, and you generate a residue which is comprising of high molecular rates and which goes to pitch, bitumen, that for paving the road or internal fuel oil. But both these commodities are of low value. So therefore, if we have to sustain the margin in the refinery, we need to convert those in valuable products. Then it requires conversion. When you talk about conversion, there is a process called cracking. Cracking is essentially breaking the molecules into smaller molecules. But when you do so, there is a reaction called body condensation reaction, and that produces coke. When coke is there, we have to handle the coke. There is a thermal cracking process where coke comes out as a petroleum coke. Now this petroleum coke, if it is of low sulfur, it is used for anode grade electrode in aluminium industry. But if it is not, that sulfur is higher, then what happens that we need to burn as a fuel. But the moment we burn as a fuel, sulfur dioxide comes out. So therefore, as far as pollution norm is concerned, gradually the use of petroleum coke as a fuel is coming down. So in order to add value to the operation, we need to convert that. So this is the slides. If you see that this is the distillation, and these are that conversion cracking. There are several fillet coke or this breaker, fluid catalytic cracking, and there are some processes where we do the molecular rearrangement. So molecular rearrangement means carbon number remains same, aromatics having more octane number. So if you have to have more octane, you have to have more isomers, more aromatics. So that precisely is done. There are three processes: alkylation, reforming, and isomerization. So it is the primary separation process, then catalytic cracking, hydrocracking, thermal cracking, then molecular rearrangement, and these are product treatment. Essentially, the purpose of product treatment is to reduce the sulfur and also improve. There is a specification for diesel called cetane number. Cetane number, higher the paraffinicity, higher is the cetane number. So that's why those processes require hydrogen. Now, this is to give an idea that when we set up a refinery, our feedstock is not same. That's challenging because it varies from crude to crude. So therefore, enough flexibility is to be there in the refinery so that even though the intermediate fractions they vary in the amount, we are able to. So API gravity is essentially that higher is the API gravity, lighter is the crude. So depending on the API gravity, if you look at that residual part, it is increasing. So suppose today we are processing this crude and tomorrow we are getting this crude, this fraction goes up. So we should have enough flexibility to handle this stuff. We cannot accumulate that in our refinery. And as I earlier mentioned that to crack this, there are three processes. All are catalytic cracking. It started with thermal cracking, then catalytic, then hydro. Here we use catalyst. Here we use catalyst and hydrogen together. When you don't use hydrogen, then the product are in olefinic in nature, so we have to take care of that part. Now this is just one slide to give you an example that how the petroleum industry, how the researchers have done extensive research to come out for a solution. The problem is that when you process a heavier fraction, there are co-precursors and they deposit on the catalyst. The moment they do so, they essentially deactivate the catalyst because they block the active side of the surface of the catalyst. There is another one important parameter is that there is some atoms, some heteroatoms like nickel and vanadium, they also deactivate the catalyst. So whole invention, whole research and development was around it. That how do you take care of the co-precursors, don't allow them to form coke, and even if they form, how do you burn it to regenerate the catalyst without causing deactivation to the catalyst, and then how do you mitigate the detrimental effects of the metal. So a lot of patents have gone in the industry, and people have, different companies has come up, and at R&D Center of Indian Oil we also done extensive work in this area. So if I summarize that what is a petroleum refinery, that we are processing crude, but what is happening to the crude over a period of time, we have consumed the sweet crude or the paraffinic crude. So there is a deteriorating crude quality, and as I have seen that shown in the earlier slides, once that happens, your residue content increases, and we also have higher impurities. On the product side, there is a more environmental concern. Recently, all over the world, there is a specification called Euro 6. In India, we say Bharat Stage 6, BS6. And that specification is very stringent in terms of sulfur and other properties. So when your crude quality is deteriorating, your product specification is getting enhanced, improved. But that creates a margin. Technology is there, but more processing involves more utilities, more hydrogen, and that costs you money. So how do you sustain the industry margin? That was the challenge. That challenge was mitigated by the innovation in the technologies. So we also worked very extensively. And one of the important ways to address the margin is that you diversify into petrochemicals. Because petrochemicals are of higher values. They are more valuable than the traditional fuel products. So part of your crude you convert to the petrochemical. So we have been assuming that, following that kind of strategy. This is a slide where typical refinery configuration is there. Due to paucity of the time, I am not getting into the details of it. But what I want to make it out that except catalytic reforming, all the technologies we are having in-house. And this blue background, they are open air technology, distillation column, naphtha splitter unit, propylene recovery unit. These are all. So those design also we can do. So today Indian Oil is in a position to build a refinery on its own, based on its own technologies, only except catalytic reforming. But we have also come out with a process which is a substitute of catalytic reforming. In reforming, we will be getting an octane number of around 100, but we have a process where we can get octane number of 125. So therefore, although we do not have a catalytic reforming technology, but we have some alternative technology whose output is much superior as compared to the catalytic reforming. Now, so far, we are in refinery. Our mandate was to supply the energy in our country. We say an energy of India, Indian oil. But now there is another phenomena was going on around the world, that was the climate change. So there are a lot of mishappenings were there around the world and people were suffering. And this phenomena was identified way back in 1972. But in the name of mankind's civilization, progress of civilization, we are consuming more and more energy. And that caused the greenhouse effect, resulting in the global warming. Now look at this curve. So this is the pre-industry level temperature, average temperature on Earth, and with time it was increasing. Now this is the observed temperature. If we did not have the human activities, this could have been good like this. So because of the human activities, the temperature has gone up. And predominantly it is in the last half century. Now if you look at this graph, how it has been contributed and how much from where, gas, oil, coal, these are the major contributors. Now these are the energy we require, everything we do. When I studied in this college, in this university, the number of cars from Calcutta, what was there today is manifold. Where from you will be running the cars, you require energy. So civilization and energy, they will be going hand in hand, and carbon dioxide is working against that. So what, as a mankind, we want? Should we stop the progress in civilization? So how to move forward from here? Now scientists have predicted that if we need to restrict the global warming to a level of 1.5 degrees C, because their prediction is that it is a threshold limit for major ecological tipping points. Therefore, the efforts would be there to restrict it to 150. So now we are in this level. If we have to go that to a level of 150 by 2040, these are the things we need to do. So there is a orange color, that is CCUS, that stands for carbon capture and utilization. So there is a lot of emphasis that you have to capture carbon dioxide and you have to convert. But carbon dioxide is one of the stable molecules. Even if we can technology for capturing carbon dioxide, but what you do with the carbon dioxide? How many chemicals you will be able to produce? What is the volume of those? Is it possible to convert whatever carbon dioxide is generated to a product containing carbon dioxide? Perhaps not. Therefore, carbon capture is there, but carbon capture utilization. People have also talked about enhanced oil recovery, but again that carbon dioxide comes out. Then people have started putting beneath the earth, but it is not established that what is the long-term implications. So a lot of skepticism is there around that. So although it's a popular buzzword that CCUS, carbon capture and utilization, but there are real challenges to push that concept through, that we will be generating, producing carbon dioxide, capturing that and converting back to some chemicals or some other usable products. So in 2021 in Glasgow, there was a conference of parties, they call it COP26, because it was 26 COP. And there our Prime Minister, Sri Narendra Modi ji, predicted, announced a Panchamrit, 5 parameters for India in the domain of energy and that climate change commitment. What are those? I am reading this because it is important to note that India committed that by 2030, it will be having 500 gigawatts of renewable energy. 50% of its power capacity to be non-fossil fuel source. Now, more than 70% of our electricity comes from coal, and carbon content of the coal is the highest. So therefore, having such kind of 50% of the power will come from non-fossil fuels. This is a huge commitment. Reduce carbon emission by 1 billion tons as compared to now by 2030. Reduce carbon emission intensity and then reach net zero by 2070. Now when we do so, the foremost challenge is that phasing out of coal. We are dependent so much on coal over a period of time that anything we think about without coal, it's a major challenge. Then solar power plants, windmills. So each is having limitation. Windmills, the wind direction is not same. There is a problem of productivity. Solar power, that it is in the daytime and night time it is not there. How do you stabilize the grid with the solar power? There are challenges. Then there are other industries other than the energy industry like cement, steel. They also emit a lot of carbon dioxide. So we will change the technology the way cement and steel are produced today. And vehicles are run on that diesel and gasoline. So can we switch over to electric vehicles? If we switch over to electric vehicles, where from electricity will come? There are many people, they are propagating of hydrogen, that hydrogen as a fuel. So when you burn hydrogen in an engine, you get H2O, no CO2, fine. But where from the hydrogen will come? If you look at the nature, wherever the hydrogen, carbon is there, only one compound that is without carbon, that is water. So the ideal way of doing that, you do the electrolysis of water. Then where from the power will come? How do I do the electrolysis? So it's a chicken and egg problem. Ultimately, if we have a renewable power source, and then we split the water and produce hydrogen, and use that hydrogen as automotive fuel. That would have been an ideal situation. But renewable power is costly, number one, and it is also not, there is a limitation in the capability because you cannot have solar panels everywhere in the country. You cannot have windmill across the country. So the production from windmill and solar energy also is, so we need to think something beyond that. So India has to do all these things within a couple of decades, and that is a huge challenge for India. Now from here, let us look at what the different agencies, international agencies, they are predicting, they are forecasting about energy mapping. This is one agency, that World Energy Outlook. They are predicting this, that by 2040, total energy demand is, now the first three bars, they are coal, oil, gas. What they are predicting that still in 2040, the contribution of the coal, oil and gas is going to be there. And there are other energies like hydro. So this is, in this side, we have that, this is the absolute amount, million ton oil equivalent, but here is the percentage pie chart. From, if you read this, coal is coming down from 27 to 22, oil and gas and other renewables are increasing. Now, this forecast can be wrong. There can be some error, there can be some mistake. So I have looked at a couple of other data. This is from another source, World Outlook, Organization of Petroleum Exporting Countries. They are predicting like this, is that the 14, 20, 30, this. Look at oil, still continuing to be measured, coal, gas. Now the trend is oil is coming down, coal is coming down, gas is increasing, nuclear is marginally, biomass and other renewables. It is almost very close to the previous one. Now this slide, I have tried to compare global versus India so that we can see that what is going to happen in global and what is going to happen in India. Now, talk about coal. Global 26, 19. India 44, 30, 34. Direction is same, but the delta for India for coal is much higher. Red, oil, 26 for India, 26. It's percentage in the total energy, so not much change. And then your that green one is natural gas, 6 to 11. So there is an increase. So all these sources, they are essentially speaking directionally same. There may be a variation, but that variation is there when you try to focus any future scenario. So that indicates that oil, gas is going to stay. If oil and gas is going to stay, will we operate the way we are operating today? Or is there a need for review of that and coming out with an alternate strategy so that we meet the twin objective of supply energy along with that mitigation of the climate change? So now we are coming to India. India, the refining capacity as on today is about 200, this is 251, we have a total capacity. These are different companies, Indian Oil, this. So there is a research group, PPAC, Petroleum Planning and Analysis Cell. They predicted that if we have to have energy security in India, we need to increase our refining capacity from 251 to, so by this year we should have this. Now we have been talking after that COP26, the net zero, we have been talking so much that the refining industry is now getting a least importance. The decision maker, their dilemma is that any project they approve, whether they will be able to get the return on the investment or not. How long this kind of fuel will be there? If there is sudden inroad of EV, overnight the gasoline and the diesel sale will be hit. At that time, whether the oil companies or petroleum companies will be able. So this is a crossroad, very difficult to take the decision because the scenario is slightly hazy, slightly smoky, and that has deepened the growth of refining capacity in India, at least in the last 5 years. So now the point is If India has to grow at the GDP which has been predicted by different experts, we require energy. We are already importing crude. Anything we can do with non-crude based, it is fine, but everything comes at a cost. So if Government of India does not give subsidy for renewable fuels, it is difficult for renewable fuels to compete with the conventional diesel and gasoline. Now already our part of these products, because of the developing nature of our country, there are subsidies. If you look at the coming 3 months, whenever there is an election, we are prohibited to increase the price. Look at the price structure. How many of that is getting by company and how many is going to the Government of India or state government as tax. So this is, in this backdrop, the entire thing is such a smoky. What kind of decision the decision makers will take? There is no assurance. Anything can happen. And if we delay the decision making, then our energy security may be compromised. That is the trade-off we are seeing today. So this is just summarize what I say is that important point of to note that power generation to be more than tripled by 2050. Just this statement, 70% of the power is coming from coal. Tripled by 2050, what will be the source of this electricity? If this electricity cannot come, whatever development we will be talking about, those will not be sustainable. Even the incremental energy, if we can manage from the renewable sources or alternative sources, that itself. So we need to look at this aspect with real-time data and with different studies and then take decision for the country, because otherwise, if any starvation of energy is going to negatively impact the growth of development in our country. So we have been talking about several alternate fuels, several renewable energies like biofuels, biomethane, this is hydrogen blended CNG, hydrogen, battery fuel cells, solar energy. People are talking about CO2 capture. Then some people are talking about gasification of biomass. But whatever we do, something or other will be there. People are predicting it is not monopoly of anything. It will be a existent. Multi-fuels will be there. Now, how do you produce them? How do you store and distribute? And how do you supply to your consumer? India took 75 years to have a distribution network for gasoline, and in my village where I stayed, the petrol was available only 3 years back. So when you talk about energy hydrogen, how do you have a pipeline network or any other supply logistics to supply energy in a vast as country as vast as India? So there are issues. If you do not do all those in a very seamless manner, what I touched upon, that energy security and then energy affordability. This is a very important aspect in a country like India. We may have the energy, but what is at what cost? If government continues to provide subsidy, government developmental projects is going to be affected. And then sustainability. We may have that something, but can it sustain it? So whatever the solution we go for, we need to keep this in mind, particularly the very different nature, very different requirement of our country. Now, when you talk about emissions, the greenhouse gas emissions, there are 3 scopes, scope 1, scope 2, and scope 3. I have mentioned that scope 1 and scope 2 are the emissions while you are responsible. I am doing the refinery operation. I repair a furnace. When I have a furnace, I will be having a flue gas. Flue gas will contain CO2. So I am polluting the environment. That is scope 1. Scope 2 is I am consuming electricity. Somebody is generating electricity. He is emitting carbon dioxide. So if I take electricity from him, indirectly whatever I am operating my refinery, I am also the responsible for it. So this is scope 1 and scope 2. Scope 3 is that suppose crude oil is being produced, there energy, crude oil being transported product is transported, energy, those I am not responsible because I am not directly. So Indian Oil has committed that seeing the commitment of the nation in an international forum, Indian Oil has committed to attain net zero in terms of scope 1 and scope 2 by 2046. That itself, for a company like Indian Oil is a Herculean task because we go by this slogan, Pehle Indian Free Oil. So whatever the Indian interest, Indian Oil will have its same interest. Business is not the priority. We will be doing the business, but we have to take care of our nation first and then the business. It is not changing. Next. Yeah. So the strategy for Indian Oil, very briefly, is that efficiency. If you talk about efficiency, suppose you are operating a car, how much efficiency is there? You are operating a AC, how much efficiency is there? How much energy we are able to use? How much is getting wasted in that process? So efficiency or majority of our appliances or majority of there, we do not have any sensitivity, any focus on the efficiency in a country like India. So the same thing happens for industry also. So we have seen that there is a huge opportunity to increase the efficiency, and that is the first we are targeting. Then blending of biofuels. Blending of biofuels is that in gasoline we have started blending ethanol. That ethanol is coming from bio. So when we do so, corresponding amount of gasoline production from crude we are avoiding, and by doing that, we are essentially including more and more renewable resources than the crude. So today Indian Oil is blending about 10% ethanol in gasoline. We have a target to go for 20% in 2025. So 10% we are producing for molasses, sugar industry. But when you go beyond 10%, we do not have sources for ethanol production. So we have gone ahead from paddy straw to produce ethanol. So we have a technology to produce ethanol from paddy straw. And we are setting up a plant in one of our refineries. And that is bioprocess that uses enzyme. Now this enzyme is available in one of the country in the world, and that is extremely expensive. If we have to use that kind of enzyme, then we will not be able to expand that process. So therefore we have our own enzyme, and we are also putting a plant for enzyme, the commercial production of enzyme, so that if we are successful there, we will be replicating that, producing ethanol from paddy straw and blending that ethanol into gasoline. Then there is another product called biodiesel. We have not been so much successful, but technology is there. There are certain seeds which are not edible oil, and we can convert to bioesters, and then bioesters go very well to the diesel pool. And then we are also producing CBG, compressed biogas, which we are blending with natural gas. Now compressed biogas, again, the technology is there in the age-old. We have a gobar gas plant that is also a biomethane process, but we thought that with that industry scale, we cannot have the unit. If we have to have industry scale, we will have to look at the economics, and then the process efficiency should be much higher. So we have come out with the process of production of compressed biogas, which produces the biogas yield at much higher. How did we do that? It is all by that effect of enzyme, which is synonymous to catalyst in the petroleum refining process. Then we have also seen that there is the optimum combination of refinery units, and by doing that we also can reduce emissions. So we have great focus. Another important thing is the green power and green hydrogen. We require power, so we have set up a lot of solar unit, a lot of windmills in different parts of the country, putting the grid, and we are planning to draw the renewable electricity for operation of our refinery. Then for hydro treatment, we use hydrogen. Traditionally, hydrogen used to be produced from naphtha. Now we are switching to natural gas. By switching from naphtha to natural gas, we are reducing the carbon intensity. Our further plans to use green hydrogen. Green hydrogen is produced by splitting of water, employing green electricity. So if we can produce green electricity, we can use that. We have putting two projects. One is at Mathura refinery and another is at Gujarat refinery. Then feedstock diversification. There is a possibility that I have a biomass. I can have a biomass pyrolysis, and that pyrolysis oil can be processed along with the crude oil. So we are also looking at that. We know we have a project with IIC Bangalore, which is a very advanced stage. And based on this initial success, we are going to put up a demo plan. Then co-processing a vegetable oil. If we have any vegetable oil which is not edible oil, because we are also importing edible oil, we have a process whereby we can produce and co-process that. Carbon capture and utilization, we have our own process for carbon capture. We are going to demonstrate in South India, one of the companies who produces soda ash, they use CO2. So they have some plant and we are retrofitting that plant. If we are successful, our plan is that we will be capturing CO2 from our refinery and giving it to at least fertilizer plant. They will get CO2. And then we are looking around the other industry who can use the CO2. The work for CO2 conversion is on, but still not major success we have achieved so far. Then Indian Oil will be going very massive way afforestation. Already in our township we have green coverage we have increased in the last 3 years, and we have a very concrete plan to improve that to a great extent. But all this when you do, whatever your margin, if there is no margin, sustainability of the industry is not there. It is not charity. So when we are addressing the energy transition and CO2 emission by all these approaches, we also have to take care of the margin. And that we are doing by diversification into petrochemicals, specialty chemicals, and there are certain other products called which are petroleum coke based, needle coke and CNT. Now I have a next. Petrochemicals, that anything we use the plastic, that plastic we call it plastic because of its behavior, because when it is molten it can give the sheer plasticity. Now look at this data, that per capita plus the polymer plastic consumption for India, 11 kg, China, 28 kg, US. So if India aspires to become a developed nation at some point of time, naturally our petrochemicals consumption will go up. Where are we now? We are importing majority of our petrochemicals today. And then there is another problem, whatever the smaller way we are using, then there is a recyclability of plastic everywhere, every city you go, every train line you move around that is the single-use plastic. Government of India has, I have referred, okay, please. So Indian Oil is focusing on that to a major extent so that we can improve our petrochemical intensity. We are operating now at around 5%. By 2030, we will be reaching 15%. That means 15% of our crude will be diverting to petrochemicals. Next. So these are we have reconfigured some of the processes to fit these emerging requirements. These all processes are oriented to produce either petrochemical feedstock or specialty chemicals, co-processing of plastic in the existing unit, needle coke and CNT. So these are the technology which we have come out by looking at the emerging scenario. So everywhere we have success, either we have already commercialized or we are going to set up commercial units. So this is one example. We have a technology called in-mass technology which produces propylene and ethylene, and with the precursors for polypropylene and polyethylene. We have set up 3 units in our company, and these are the units that are already designed up. So based on an indigenous technology, we have built a unit capacity of 17.25, and similar kind of there for other units also. Next. So this is another delayed coker technology. It is a century-old technology. So what is there? Because we have research there to do 2 things. That energy consumption in delayed coker is much higher. The pet coke yield is much higher. We have addressed those 2 issues so that energy consumption gets reduced, and we reduce also the coke yield by 4 to 5%. Then co-processing of waste plastic. Whatever waste plastic, if we can collect, we can co-process there. We have already demonstrated in our Digboy refinery. And last that, when you talk about EV, there is an electrode requirement in EV, and it requires a special coke which is called needle coke. We have a technology we produced in a very small quantity. Now we are going to set up a commercial scale plant for production of needle coke, which will go two products. One is the graphite electrode for steel industry, and another is the electrode for EV industry. Now biomass is, we talked about biomass. This slide gives you the indication what is biomass production and what is the surplus availability. If we look at the surplus, it is about 179 million tons per annum. And everything, collection of biomass, aggregating the biomass, there are issues. So if we are able to do all biomass, there is a potential of 50 billion liter of liquid biofuel per year. But we are going very strongly in this area, but what we are seeing, the aggregating of biomass for the industry scale is a real challenge. Now this is I talked about that compressed biogas. It is a biomethanation technology. We are having two plants. One plant we are operating, second one, Gorakhpur, it is in construction, and two more units we are going. So biomethanation here, our biomethanol is much higher, and the purification cost is much lower. So therefore we are edging over the other competing technologies. And this Gorakhpur plant, it uses 200 metric ton of paddy straw per day. Imagine that 200 metric ton of paddy straw. So whatever paddy straw is there in that Gorakhpur region, we will be using in that plant. And this is owned by Indian Oil. Owned, developed, designed and owned by Indian Oil. So this is the national biofuel policy. Government of India mandated that 20% of the gasoline will be from ethanol. So we have already done 10%. We are working towards there. But when you do so, the ethanol from molasses we have exploited. We cannot go beyond. So we have bring the concept of second generation ethanol, where feedstock is the biomass. So we are setting up one plant at Panipat refinery. And that is the 2G ethanol. Paddy straw will be converted to ethanol. Now CO2 capture, I already touched upon it. We have a very lucrative output of a process. It's a patented process. And in the month of April next year, we are going to demonstrate it. If we are successful, this will be a game changer technology for India, because there are many CO2 sources we can capture and we can see the possible use for the aviation. Next. Summary, I have already spoken that India energy demand is going to increase. The power demand, electricity demand going to be tripled by 2050. Alternate energy potential is there. Whatever we can do in a small amount, we will be able to substitute the crude import, because we are importing more than 85% of the crude, so that will be great. But whatever solution you talk about, the life cycle analysis is very, very important, as I gave the example of hydrogen. Prima facie hydrogen, if you burn, you will be getting water, nothing, no CO2. But where hydrogen is coming? Therefore, we need to look at the entire cycle for any selection of any solution. And when there are multiple energy, you are having solar, wind, that bio, how do you keep balance? What is the price? Because if pricing is not there, you will not be having your investment return. You will not be going for investment. So the coming years is going to be more dynamic in nature, and how we are able to handle, address that in a holistic manner, that will be deciding that what is our energy security, energy affordability, and sustainability. Next. Last slide. So from here, whatever I have presented, that petroleum refining is going to stay. But it may not stay the way it is now. There are certain things, transformation are necessary. We have already taken that journey towards that direction. And we are diversifying to petrochemicals, strengthening gas portfolio. Indian Oil did not have the gas portfolio. We are foraying to new energy sources like alternate energy, solar, wind, and we are focusing on value addition to the existing refineries. And our carbon capture technologies may be a game changer technology for Indian Oil as well as India. Now, coexistence of multiple fuels, there is one from here to where. And the transition. This transition is more volatile. How to manage the transition? So therefore, the government policies and the coordination among different players are very key. We need to talk about, we need to look at more holistic manner for the benefit of our country. Then only there will be a proper energy transition and energy availability, addressing sustainability and affordability. So thank you so much for your attention and for the great opportunity. Last slide, just 1 minute. Last slide. That this, I included this quote, that we cannot change the direction of the wind, but we can adjust the shades. Essentially, we are trying that in that. Thank you so much.
Thank you very much. I know this subject is very important and close to our heart, and only giving half an hour is not enough. But you covered a lot. I know that we went past the time a little bit. So let me invite a couple of questions from the audience, both online and in person. And the question, so my request to you is to keep the question short so that we can understand and answer.
Good morning, Devashika. My name is Devjit. I'm a pass out of this university. I work in a company called Chem Engg. So my question is, when India, the per capita consumption of petrochemicals product, plastics basically, is less compared to the world, it is probably the 1/5 in the developed economy. So there are technologies coming in Middle East and North Asia, especially China, where they are getting crude to chemicals kind of technology. And the major licensors like Chevron, Lamas and that. So is Indian oil or the Indian industry, from your outlook, will be going ahead in this scenario?
The crude to chemicals, when we talk about COTC, COTC is talked about, different companies have protected a figure that, so we also having our own configuration for COTC. So building a COTC new refinery is fine, but if you have an old refinery, transforming that to a COTC concept fully, perhaps that return on investment we have already examined. So we are going in a very different way, and we are increasing, we have identified some of the refineries for journey towards COTC. And there our 2030, that petrochemicals production is going to be about 15 to 20%. But we have seen it is not possible, or it may not be feasible, or it may not be prudent to go for all the refineries, because some of the refineries, their capacity, because at the end of the day, everything is return on investment. So we are going ahead. You are right that we may not have all the technologies, particularly in the petrochemicals area. So we are, whenever is needed, we are sourcing the technologies from the providers, and we are very, very alert and active in that direction.
Like, there are further integration available with the coker. I mean, when we get a coke, like we either select propane coke or heavy coke. What about the gasifiers? Because I saw in one of the plants including the one largest refinery and gasifier. I have worked there for some of my years. Is it a successful technology in your view? Is India looking into that?
Technology is successful. Petco gasifier works. But if you talk about the economics, there, so Indian Oil also has studied it, and we have abandoned that idea for petcoke gasification because we have found alternate use of petcoke. So petcoke gasification perhaps we are not moving. Because you know the Reliance has put up, and they are also facing a lot of problems, and they have gone in a big way. They did research for 10 years, and then only they cleared. So we also did the study, and our conclusion is that let us not get into that.
Okay, so do we have any question from online attendees? If you can, if someone can read from the chat, or online attendees can fire a question.
Is there any question on chat box?
Okay, one last question from this audience.
My question is
wants to produce biodiesel.
We have seen we are having biodiesel and power. Biodiesel, are you having from cattle?
Let me just tell you, biodiesel, if we can produce it, we can directly blend to the diesel.
Yeah, that is right.
Now today we are not, the mandate is 5%, we are able to only blend to a 0.8%. So still there is, so if you have a biodiesel, there is no way. But there is another vegetable oil. Biodiesel is a ester. Vegetable oil is a fatty acid. So if you have a vegetable oil, we can process in the secondary processing unit along with the cracking unit. We have done a commercial trial, but availability of vegetable oil on a sustained basis in a commercial scale is also a issue. So we are not going on a regular basis, but we did the trial and we have the know-how and technology ready.
Okay, thank you. Thank you, Devasys. It's an impressive talk, very important topic. So please join me to thank Devasys once more for bringing the next presentation is online. It's and to be given by Warden Secretary, photometallurgy decomposition of cycloplasmin, taxosin drug, proposed integration mechanism and antimicrobial study. So, Warden Secretary, if you are ready, and we are ready here, technically, you can begin. Are we ready? He hasn't joined? Alright, so if the speaker hasn't joined, then if there are more questions from the audience for Devasys, and if Devasys agrees to answer them, we will continue because our next speaker hasn't joined. Alright, so, okay, Jyoti, you have a question? Alright.
Except just two questions actually. Chevron very recently is executing one project in what's called A4G, fatty oil and grease. They are producing biofuels, which is natural diesel and fuel gas. And they had a pilot plant, and now they are increasing the capacity with significant extent. So, what I understand from your presentation is in future India is also looking for this kind of. So basically you have first a pre-treatment kind of facility followed by
Then you talk. Slide there.
And due to this consumption, occurs and has one special features it has ability to binding complex with the iron metals. And apart from this, it has a different reaction bioactivity and toxicity. Now, these are the objectives of my research. So I have used basically I have used homogeneous oxidation process where the hydroxyl radical is being generated to rebuild this glass, and whatever means the utilization product are being formed on the utilization over the glass that I have studied here. And apart from this, the decomposition behavior of the iron complex and their impact of mineralization. And again, too, I compared this study based on the single active research document. And finally, I have shown, I will be showing here the viability index and control activity. Now, this is some optimizations work here. So here, here's to fix optimize amount of the iron, which is as a catalyst and hydrogen oxide. So here, it is found that if we increase the iron and hydrogen oxide molar ratio, so the drug integration efficiency will increase, and at around 0.125 molar ratio, it has been found for using maximum mineral and the large percent of mineral resistance to this central process, and the optimum maximum time I have taken for 45 minutes and optimum pH 3.5, and I have conducted this experiment at room temperature. Now I optimized the pH, basically an acidic pH less than 3.5 pH, so it has been found that maximum molar efficiency, and at this pH basically we got maximum emissions of hydroxyl radical, which is act as a net oxidant in this process. Now here I have studied three atomic oxidation process, homogeneous atomic oxidation process, chemical propagation process, and UV process. So chemical process basically the hydrolysis in presence of hydrogen peroxide, and photographic process the hydrogen and heating process in so based on these studies I have found that CIP resistance was found in photographic process compared to the other two processes. In the other percent, and the same things happens in the case of using that is the mineral efficiency. Hence, I found that the photographic process shows the maximum mineral efficiency in terms of UOC. So, what the maximum mineral efficiency for photographic process compared to other two processes? Because in photographic process, the additional gravity force occur in the UV, because when the iron acts as a catalyst here, and when this acts, iron reacts with hydrogen oxide, or in the hydroxyl radical. Apart from this, iron will be able to form Chile complex with the OH dot. Again, in presence of UV light, again this hydroxyl radical will be removed fast. Okay, so due to the additional effect of UV light, so we got more hydroxyl radical, and subsequently it increases the mineral efficiency in case of photographic process. Now, hence radiation from mean oxidation number of carbon. So in this extent, the basic idea I have taken that whether my graph is negative or not, that can be explained from the MONC. So if you increase the MONC, that is the mean oxidation carbon number, we know the mean oxidation carbon number -4 and maximum +4. So minimum -4 happens for methane and maximum for carbon dioxide. Okay, what ways the MCV is changing in case of the G process for prototypical, electron and UV process. So it has been found that for prototypical process it is increased minus 46.1, and in case of electron process 1.68, and in case of UV process it has been found at 1.0. That means the prototypical process is more efficient and more potentially degrade this graph because the redundancy is higher compared to the other two process. And again, by using this formula, we have calculated this MMC. Now, I have developed a kinetic model regarding this calculation study for the chief of advanced oxidation process in terms of chemical and UV process. So, however, the there are several reports where many people have reported that drug regulations follow the pseudo-fast order kinetics or fast order kinetics. But as per my experiment, it has been found that it follows the second order kinetics. Hence, this is the reaction. CIP reacts with hydroxyl forming the oxidized product. So, hence, I have developed the two kinetics. One with respect to change of the degradations, means change of the concentration with respect to degradation product, and again the change of the hydroxyl concentration with the time. So, by combining these two equations, so I have developed
ये प्रोजेक्टर का सेटअप में कोई
and again
एक सेकंड
हाँ
the
इसलिए नहीं हो
kinetic constant here. So for photometric process,
ये जो ओरिजिनल बैनर है ना वो भी इधर से नहीं वो उधर पे तो कोई कुछ नहीं किया इधर से किया क्योंकि सुबह जो हम चलाए थे ना उससे नहीं है बाद में कैसे
and the process so the minimum efficiency for hydroxyl with the lower electron. Now this is so actually I have taken the idea that my graph is degrade or not, whether it is susceptible to form the Gillette complex with iron. So basically, from the mass transfer basically evidences that my graph is able to form a complex with the iron. Hence, we got the different mass number here, and my graph, this is our superposition graph again mass number 332 not 2, and along the main metabolite is being formed here, having mass number 261.1, along with the other mass number we got also. And hence, we got this mass number 386.02. This is equivalent to this complex CIP43. That means the iron below the iron, it has a position number 6, and CIP means it is means bidental digit. If I go back to slide here, you see here, you can see here, basically one is this group here. So by decompression, so it would act as a one binding site and another binding site is secondary amine site. So it will form the bidental digit, and we know it has number 6. That is why the CIP3 modes of CIP will coordinate with the iron, and we got the corresponding mass number 386. That means it is clearly evidence that the iron is susceptible to form a Gillette complex with the CIP graph, and these are the corresponding other. Now I propose the mechanism of process, and already it has been well proved from MS study also And recently I have published this paper. Here the CIP molecules, congratulations CIP molecule to the photovoltaic process. I got 14 number of given number of products, and I proposed the different pathways so that we got the different products, and this and several reactions mechanism are also involved here, like deprotonation reaction, decarboxylation reactions, and the hydroxylation reaction, dehydration reactions are also involved here. And along with the evolutions of the smaller molecule, that indicates the removal of TOC, means reductions of the mineralizations. And here this mechanism basically signifies that whether my chelate complex, I have already proved in my MS study that we got this chelate complex, and also this chelate complex is being formed also. And from the MS study, I have again from my proposed mechanism, I have proved that this complex, after the formations of the complex, again this complex is susceptible to degrade again for the to form the several daughter product in presence of UV light, because this complex is very means sensitive towards the UV light. In presence of UV light, this bonding is breaking off, and ultimately we are getting this daughter product having the mass number 261 through these pathways. And this is the well established mechanism, and also means it is evidenced by MS study also. Now, again, I am moving to my next study, the antimicrobial activity study for the CIP, and hence I have studied to comparative study of photophotone process and UV, means here the homogeneous advanced oxidation process and heterogeneous advanced oxidation process. Hence, the photophotone versus UV photocatalytic. Basically, I have used here titanium dioxide. However, I am not including this result detailed study in my research work here in this slide. So it has been found that the photophotone process also shows the means lesser number of cell death, because the in photophotone process shows the 55.6 cell death, where the UVP process means heterogeneous photocatalytic process in presence of TiO2 66.8%, because we know the in photophotone process the huge amount of hydroxyl radical is being formed, and again this hydroxyl radical is susceptible to degrade by drug with a very small molecule. That is why the means very less toxic compound is being formed. That is why the cell death will be low. Whereas the UVP process, the due to the lesser amount of hydroxyl radical is being formed, so still in this process, still the larger molecule is being formed, which are very toxic in nature. That is why means comparatively larger number of cell death will happen. So that is the comparative study, and also I have published this paper recently. Now I am doing with these extensions of my work. I am doing now the mixer study. This is my single treatment, and this is the CCT. CCT means I have taken the another two drug here. Apart from the CIP, I have taken another two drug, chloramphenicol drug and the dipyron drug. So two drugs, ciprofloxacin and chloramphenicol, these are two antibiotic. Another one drug, dipyron, is the analgesic drug, that is the painkiller type drug. So, this is the single treatment, and this is the mixture treatment. So I have found that in this respective four process, the CCT means mixture treatment shows the lesser removal efficiency compared to the single treatment due to the common ion effect. And in the for both case, single treatment and CCT mixture, I found that the photophotone process significantly showed the higher removal efficiency in terms of BI, that is the biodegradability index, and antimicrobial activity. So photophotone process shows the higher biodegradability index compared to the other three process, and the antimicrobial activity also so lower for photophotone process. And this is my pure drug,
BI and AMC. So now I am concluding my research work. So under degradations of CIB, I got under optimal conditions at pH 3.5 with the iron to hydrogen peroxide molar ratio 0.125. The maximum removal efficiency COD and TOC 47.1 and 37.9%, and the residual hydroscale concentrations was found 0.792 micromolar, determined by DMSO probe for the 30 minutes for photophantom process, and also the 25.7% unreacted drug still there, and mean oxidation carbon number increased from 0.128 to 2.8. That is the initial mean oxidation carbon number, and this initial mean oxidation carbon number increased to 2.1. That means my the oxidation number is being increased, that indicating that organic molecule is being degraded, and 11 number of primary daughter ion have been found, and it follows the second order kinetics model with respect to both the daughter products and hydroscale radical concentration, and the rate constant for CIP and DB's oxidation obtained 2.1519 to 5.07 into 10 to the power 3. And the model gave an initial hydroscale radical concentration of 11.3 not to 11.74 micromole. So these are the main output from my research work, and still my work is going on in case for the mixer drug. So thank you. So now it is open. Now I am ready to give the question if you have any queries.
Yes. So, Dr. Giri, thank you very much for this wonderful presentation. And please join me in thanking. Is there any question from this audience? Is there any question from the chat?
Hello, sir. Am I audible?
Yes, we can hear you. Is there any question from the chat room? Okay, so Dr. Giri, I do have one question. If you can tell us, what would be the half-life?
Hello.
Yes, what would be the half-life of degradation process? Meaning, if you get high power of this drug, by what time you reduce to 1.5 gram?
Hello, sir. Sorry, sir. Yes.
Okay, what is the half-life of degradation?
Hello.
Can you hear my question?
Hello, Arvindo, are you getting us?
Yes, I am hearing. It is not clear.
Okay, so let me ask you once more, what is the characteristic time for degradation mechanism, degradation process? If I have 100 kilograms of drug, how much time will be needed to degrade 50 kilograms of drug?
Yes, sir. So now, sir, now this drug is it present in solid or pure drug?
Okay, whichever way it is, let's say that it's your solid body. In that case, how excited would it be?
So this drug is not exactly what is soluble. So it is soluble in water with slightly acidic. Means lower pH it is soluble.
Okay, and I think that would be okay for now for us to move on. The next presentation to be given by Atari from IIT mixed electric membrane carbon capture and sequestration challenges and scope. So, if you are ready, please start your questions.
Is this my presentation? It is my presentation now. I am changing the schedule.
We can
We
hear
can hear
you.
you.
I
I
think we
think
can
we
hear
can hear
you.
you.
But
No, I am Sutapa Bhattacharya. As per the schedule, it is my presentation. Are you changing the schedule?
is the
Is the
order
order
now?
out?
I mean,
Okay.
so it
So
is
it is
Thomas
so much
presentation now?
presentation now.
Okay.
Okay.
Okay. So
Okay. So
you have
you
made
have made
available
available
to give your
give your
presentation
presentation
now.
now.
This
This
new
your
presentation
presentation
to be
will
given
be
by
given by
Sutapa
Sutapa
Bhattacharya.
Bhattacharya.
Safety
Safety
audit,
audit,
perspective in
perspective in
Indian
Indian
industry
industry
in
in
science. So
science.
take
So
your
take
lead,
your lead,
please.
please.
Hello.
Yes.
Yes.
So this I guess and it was my presentation.
Okay.
Okay.
Who wants
Who
to
wants
lead
to
the
lead the
presentation?
presentation?
Tell
Tell
me.
me.
In my
In my
case,
case,
can
can
tell
you tell
class
class
from
from
year
year
11?
11?
Sir, I could not hear you properly.
Okay.
Hello.
It is another one. Actually, sometimes back, Washim told that it is my presentation.
Okay.
Okay.
Please listen to your presentation.
Professor, if you want to give your talk, please do. And then
And
say
then
what
what
is
what
talk
is
next.
talk next?
Hello, sir.
Yes,
Yes,
Abhiti,
Aditi,
you
Yes,
want to
want
make
to
your
make your
presentation
presentation
now?
now?
I can present, sir.
Okay, please
Okay,
go
please go
ahead.
ahead.
We cannot
Cannot
hear
hear
you.
anymore.
So the
So the
professor
Sir,
is
your
professor
voice is not clear to me. It's so much of echo there.
we can
we
hear
can hear
you.
you.
So
So
please
please
begin your
begin your
presentation.
presentation.
You want me to start, sir? Do you want me to start?
Yes,
Yes,
please.
please.
Okay, sir. Okay. Sir, is my screen visible?
I can.
We are just getting you here.
Is my screen visible, sir?
No.
No.
Please share
Please
your
share your
screen.
screen.
Is it fine, sir, now?
Yes.
Yes.
Now it's
Now
good.
it's good.
Okay, you
Okay,
can
you can
begin.
begin.
Should I start, sir?
Yes,
Should I
Yes.
please.
start?
Yes.
Yes.
Okay.
You make it full screen, please.
Yeah, it is full screen, sir.
It's okay. Let us start.
Abhiti,
Aditi,
please
please
start.
start.
Yes, sir. Sure, sir. First and foremost, I would like to greet everyone in attendance and offer my heartfelt congratulations to the Kolkata University Chemical Engineering Department for organizing this Alumni Association meet. My name is Aditi Katari and I am currently pursuing a PhD in the Department of Chemical Engineering at IIT Guwahati under supervision of Professor Vishnupada Mandal. Today, I'll be presenting my research work on the topic mixed matrix membrane for carbon capture and sequestration, challenges and scope. So these are going to be the outlines of my presentation. First, I'll discuss the CO2 capture overview, where we will look into the reasons and effects of global warming and ways to capture the major contributors to greenhouse gases which is carbon dioxide. Then we will see the role and advantages of membrane technology over other conventional technologies like adsorption, cryogenic distillation, etc.
Abhiti, you did not see your slide.
Your slide is not
My,
changing.
Slides are not changing. Okay, now
okay,
now
okay, sir.
go back where you came from. We just saw the slide, so share your content once more, please. Share your content. Abhiti, don't follow, please share your
Sir,
content.
sir, can you tell me now? Is it changing?
Your screen came up, we are now go forward and see how it changes.
Sir, is it changing now?
No, go to slideshow. Then one will change.
Hello?
Yes, now you are seeing presenters view. Yeah, go to slideshow.
Sir, animations are not working.
Yeah,
If I show like this, I have to go to the slideshow option.
okay. Whichever way works for you, please do.
Sir, can you tell me, is it working?
We see a title page, but as presenter view, if you can one page, we are fine. Okay, go to the next slide, we'll see.
Sir, I'm really not able to hear you properly. Your voice is echoing a lot.
Okay, go to the slide show. Yes, click there, or it's exiting, I don't know.
Sir, sir, is
Go to share screen once more.
sir, tell me, can you please tell me now? Is it fine now?
Yes.
Okay, sir. Okay, sir. Okay, sir. I will start from.
Okay, start, please. This is now. This is now working.
Oh, my name is Abhiti Katari, and I'm currently pursuing PhD. It's fine now, sir?
Yes.
It's not working, still not working, sir.
It is fine. You are having
Is this working, sir? Okay,
yes.
sir. I'm going to start it now. So these are going to be the outline of my presentation into the reasons and effects of global warming and ways to capture the major contributor greenhouse gas, which is carbon dioxide. Then we will see the role and advantages of membrane technology over other conventional technologies like adsorption, cryogenic distillation, etc. And since our major focus is on polyimide membranes for CO2 capture, the next topic of my presentation will comprise the discussion of commonly used polymers in the membrane technology. Then, for an experimentalist, the current scenario in the research field is all about the synthesization of new materials and the modification of existing materials to get the better thermal, chemical, mechanical, and electrical properties. And so, in the field of carbon capture and sequestration, The invention of mixed matrix membrane fits into the aforementioned category. So, next I'm going to highlight about the commonly used film materials to fabricate the mixed matrix membranes with the desired properties to achieve high CO2 permeation. Finally, I'll discuss some remarkable results obtained by researchers in the field of CO2 and 2 separation studies. As well as I'll discuss about the challenges they encountered and the potential future application of mixed matrix membrane. So let's discuss the introduction part first. In the pre-industrial era, plants were the natural reservoir of carbon. They utilized the CO2 via a process called photosynthesis, and the atmospheric CO2 levels between 280 and 350 parts per million created the climate that let humanity build and feed the modern world. The farther we get from these levels, the more we run the risk of disturbing that balance. However, according to NASA's Global Climate Change Report, society's transition from pre-industrial to industrial stage, deforestation, and a sharp increase in energy demand due to rapid population growth in the previous decades is responsible for nearly 419 ppm CO2 emission in November 2022. So, all these anthropogenic activities have profoundly imbalanced our ecosystem. And so, due to this climate change, we can observe summers are growing longer while the winters are dramatically shrinking. So, nature requires research and implementation of the solution to the aforementioned issues. So, the following are the possible solutions. First is the reduction of energy intensity, but because of our technologically advanced machine dependent lifestyle, reducing the energy intensity seems nearly unachievable in the 21st century. Next possible solution is to reduce carbon intensity by shifting the energy demand away from fossil fuels and towards the renewable energy sources like tidal energy, wind energy, solar energy, geothermal energy, etc. Still, it is not possible to totally replace non-renewable energy sources with the renewable ones due to cost and low power density. Thus, we must work on the third solution, which is CO2 capture and sequestration. So let's move further and explore this third solution, which is CO2 capture and sequestration in more detail. So CO2 can be captured possibly by following three processes. First one is pre-combustion process, second is post-combustion, and third one is oxy-fuel combustion. According to pre-combustion process, before combustion is completed, and post-combustion processes says let the fuel burn and separate the CO2 from flue gases after the combustion is completed. And last is oxy-fuel combustion, and according to which burning fuel should be burned with the use of pure oxygen instead of air. So this will reduce the separation cost of flue gas. So report says that over 40% of energy related CO2 emission is due to the coal-fired power plants, and there are number of technologies available to capture the CO2, like membrane technology, adsorption, so many technologies. But however, Few of these technologies have environmental footprint due to their high energy demand and high capital and operational cost. So we have decided to work on the membrane separation technology. Due to its many benefits over others, like it has smaller footprint, it has high CO2 N2 loading, it is not so expensive, it has compact design, it's maintaining cost, and it has continuity operation. According to literature, membrane technology was developed in 1900, and it was utilized for gas separation in 1980s for separating the hydrogen gas and nitrogen gas. And at that time, polymer was used as a polymer, and hollow fiber membrane was created to fulfill the purpose. And the field test of CO2 capture from nitrogen was implemented in 1998. Year 2000, in the year 2000, for separation from flue gases. This brief history reveals the importance of polymers in the membrane industry. So, moving on, there are mainly three types of membranes available. First is polymeric membrane, other is inorganic membrane, and last is mixed matrix membrane. All the types of membrane have some benefits and some disadvantages over each other. For example, polymeric membranes, they have many advantages, but they suffer from the trade-off between permeability and selectivity. While inorganic membranes, their manufacturing cost is very high, and it's very difficult to obtain defect-free membrane with inorganic materials. So combining the type of polymeric has opened a new technology which is called the mixed matrix membrane. It involves the
Abhiti, your presentation stopped.
CO2 is our target. So absorption of target gas molecule
Abhiti, your network is having problem.
through membrane. This molecular sealing mechanism, this takes place due to the presence of pores onto the membrane. Like for example, commercially polyether sulfone is available with various pore width. So this molecular sealing mechanism takes place if membrane is porous. If membrane is not dense, if it is porous, then molecular sealing mechanisms take place. And the important property is the pores, which should the pores of the membranes, which should be between the kinetic diameters of the gases present in the feed gas mixture. And the last and very important one is facilitated transport mechanism. It offers the highest selectivity and highest flux when compared to solution diffusion and kinetic and molecular sieving mechanism. This is due to the fact that the target gas molecules, which is CO2, it interact like react reversibly with the carrier present into the polymer matrix. So this is the reason why membrane like facility transport mechanism is preferred over other mechanisms. So let's have a look at why facility transport is most desirable transport phenomena over others. So, as can be seen from the Zutter-ion mechanisms, the reversible chemical reaction between CO2 and functional groups, mostly amine functional groups are helpful, and this CO2 I mean this the reversible reaction between CO2 and amine functional group helps to enhance the passage of CO2 from upstream to the downstream in the membrane. And the most functional group, as I said, is which act as a carrier for CO2 to for the CO2 gas is amine groups. So, moving on to the next topic, which is the commonly used polymers. Commonly used polymers. So, the selection of polymers out of the many available options is based on many properties. Like the polymer should have film forming property, it should be sustainable at high temperature, and it should have there should be a presence of inherent amine groups, and along with amine groups like hydroxyl groups, carboxyl group, etc. So these are the most commonly used polymers. We have chitosan, we have PVX, polyvinyl alcohol, metramid, polyurethane. So like I am working on the chitosan polymer to capture the CO2 from flue gases. So because why we are working on the mixed matrix membrane, because the mixed matrix membrane enhance the properties of conventional polymeric membranes by combining the easy processability of polymers with the superior selectivity of inorganic fillers. So here I have shown this schematic diagram of how the filler material is blended with the polymer matrix, and it should have the compatibility with the polymer, the selected filler material, and at the same time it should have the ability to capture the CO2, and it should be uniformly dispersed into the polymer matrix. So, moving on to the next topic, it is commonly used inorganic fillers for membranes. There are infinite number of fillers available in the commercial world, and few of which has given the good CO2 into capture properties and easy to fabricate. I have mentioned some of their names. First one is graphene oxide, then zirconium off, which is also called UiU66, then Mill-100 iron, then HKS2 first, then ZIF8, and CNT carbon nanotubes. So all the synthesized MOF, whatever MOF or membrane you are synthesizing, we have to do the analytical characterization of the material using some analytical methods like XPS and Chem, PG, etc. So in my laboratory, I have synthesized graphene oxide and UIU66 and mil 100 iron. And here I'm showing here I'm showing the same the characterization of graphene oxide and UIU66 fillers. I have utilized these fillers. So, as we can see from the SAM analysis, UIU60 SAM and TAM analysis both, UIU66 have a spherical structure and graphene oxide has a sheet-like structure. Then FTIR analysis depict the presence of desirable functional groups. Then TGA study shows the thermal degradation of the behavior of the synthesized fillers. Then the surface area of the synthesized fillers and the synthesized UIU66 by me, it showed the surface area of around 1100 meters square per gram.
Aditi, can you please
Next, this is the schematic representation of the membrane synthesis.
Abhiti, can you wrap up your presentation soon, please?
We have followed the solution casting method to synthesize the mixed matrix. Hello, sir.
Yes, so you are running out of the time allocated to you, so please wrap up.
Sir, sorry, you are not audible to me.
Okay, please wrap up your presentation soon, maybe 3 minutes. Can you hear me?
Sir, your voice is echoing a lot. I'm not able to hear you.
Okay, continue.
I have few slides left, sir. I have just few slides left.
Okay, all right.
So this is the schematic representation of how the membrane synthesis procedure takes place. In the like I have followed the solution casting method to synthesize the mixed matrix membranes, and the fabricated membranes have achieved the desirable active layer thickness. For the synthesized membrane also we have to do many characterizations like SAM study, AFM, TGA, NMR, FTR, XPS, so many studies. Then here I am showing the FSM studies of few of the membranes which I have fabricated. Let's see. First image is showing the successful fabrication of defect-free mixed matrix membrane at optimum phases of the membranes. We can clearly see that at higher concentration of filler, higher concentration of filler leads to the agglomeration and non-homogeneity in the membrane. So it is very important to optimize the loading of the filler into the membrane before going to conduct the CO2 GSO, and EF analysis is showing how at different loading of filler, how the roughness of the membrane is changing, and ultimately it is contributing to the roughness is contributing to the CO2 permeation performance of the membrane. So these are the next. Let's have a look at commonly used combination of primers and fillers and CO2 capture performances.
So, I think
as we can see, polyethylamide is used with the zephate material, and the operating temperature was 45 degrees Celsius at 100 psi, and the CO2 conveyance of humans.
Aditi, we need to stop your presentation. Okay?
So these are some of the
We need to stop your
temperatures
presentation.
survey.
We need to stop your presentation, please.
It shows the combination of different. So, hello, sir.
Yes, we need to stop your presentation. You took more than the time we gave you. Please stop your presentation so that we can move on to our parts.
Do I need to?
Okay, your time is up. Okay, thank you. So let's
these are the.
With you more than the time we gave you.
Okay, sir. So give a few.
Yeah, we have to go back to the other. You have to complete chapter 3, please.
Okay, sir. Okay.
Continuing good, we like it, but we need more presentation which follows through. Okay, so let's have a query to make a presentation. Next one, please proceed. Thank you. Yes.
I'm sharing the screen. Let me share.
Yes, please share the screen. And again, we also have only 20 minutes. You still see your time.
You have to give access to share the screen. Yes, I'm trying, but it's not coming.
Click on it.
It is not coming, my screen. It is your screen. It is your screen.
Okay.
Can you please, can you close your screen because your screen is coming.
You share your screen, then automatically it will.
I'm sharing.
This share is not coming.
It's your screen. You can see the screen. You can see my screen?
No, we see your picture.
I am trying, sharing, but it is not coming. This arrow,
Okay, click on the arrow.
One second, I have to make it minus. I have to minimize it.
এন্টায়ার স্ক্রিনটাকে শেয়ার করো, করে ফাইলটাকে খুলে দাও।
সেটাই তো হচ্ছে না, আপনাদের স্ক্রিন দেখাচ্ছে বারবার।
না, আমি
তোমার স্ক্রিন দেখাচ্ছি কিন্তু আসছে না।
আমরা তো তোমার ছবিটাই দেখছি এখানে। তোমার ঘরটা কি দেখা যাচ্ছে তো? এবারে আসছে।
ওকে।
না হলো না।
Both your screen is free. তোমাদের আপনাদের স্ক্রিনটাই দেখা যাচ্ছে। Once more I'm trying.
না।
হ্যাঁ আমার এটা প্রেজেন্টেশনটা আছে আপনার আমার প্রেজেন্টেশনটা আছে আপনি পারবেন ওটা গিয়ে আমি 21 তারিখ পাঠিয়েছি কেন হচ্ছে আমি বুঝতে পারছি
এবারে ওনার যে প্রেজেন্টেশনটা আছে ওটা সেটাই তো
আসছে না
প্রেজেন্টেশন নেই এবার ওনার স্ক্রিনে দুটো ফোন করেছে
প্রেজেন্টেশন মোডটা টিপে শেয়ার ডেস্কটপ শেয়ার করে দাও ফাইলটা খুলতে তুমি প্রেজেন্টেশনটা শেয়ার করো আর ফাইলটাকে তার শেয়ার করার পরে এন্টার স্ক্রিন দেবে এন্টার স্ক্রিন দিয়ে শেয়ার আসবে তারপর ফাইলটা ওপেন করবে ফাইলটাকে খুলতে হবে এবারে এন্টার স্ক্রিন শেয়ার করো করার পরে ফাইলটাকে খুলে দাও আনমিউট হয়ে আছে তোমাদের আনমিউট হয়ে আছে আনমিউট হয়ে আছে
আমি এসএস শেয়ার করেছি কিন্তু আপনাদের
হ্যাঁ করবে করে এবারে ফাইলটা খুলতে হবে তো
দেখুন এটা আসছে কিনা না
স্ক্রিন শেয়ার করলে তো ওটা আসবে সেটা তো
আমি শেয়ার করেছি পেপার নাম্বার 24
Read the paper. Read the name. What file? What file is available?
No, no, presentation. Yes, no, আমার তো এটা স্ক্রিনটা আছে আরেকবার আমি ট্রাই করছি এক সেকেন্ড আরেকবার ট্রাই করছি এবারে কি আসছে
না
দাঁড়ান আরেকবার ট্রাই করছি
সুজিতদা মিলে আছে
হ্যাঁ সুজিতদা মিলে পাঠিয়েছে
ইটস ওকে নাও
এবারে সাইডে তো
ইজ ওপেন ইওর ফাইল
এবারে ফাইলটাকে খোলো
এবারে আসছে ওকে ওকে
প্রেজেন্টেশন মোডে যাও হ্যাঁ
হ্যাঁ ঠিক আছে
হ্যাঁ এসছে
ওকে গুড আফটারনুন এভরিবডি am I audible
হ্যাঁ শোনা যাচ্ছে
আচ্ছা So, thank you for giving me the opportunity to present my experience. And it is my pleasure to be present here in this particular forum because I have studied the maximum portion of my career. We have used either studies and other things. So I feel very happy to be present here. I am expressing my gratitude to my teachers who are there now, and I am starting my presentation. So before starting, I want to share that this was my experience in this institute was very nice. Still, we remember our college days. Just with these two lines, I want to start the presentation. As you may not be knowing, I am Sutapa Bhattacharya, 1979 batch, but passed out in 1981 and started my career in BRC in Bhabha Atomic Research Center. There we have 1 year training. After that, I worked 12 years in heavy water plant, Talcher, which is a chemical plant. Then I worked 13 years in Atomic Energy Regulatory Board as senior scientific officer, where I was inspector under Atomic Energy Factories rules. And after that, I have took voluntary retirement and joined National Safety Council as director, where I was heading the audit section. I have retired in 2017, and after that, sometimes I worked with British Safety Council as auditor. So this is my experience in the audit which I carried out throughout my career. So first I want to tell what is safety audit. It's a systematic and objective evaluation as per the Maharashtra Factory Safety Audit Rules 2014. It is a systematic and objective evaluation of occupational health and safety system documents and procedures. So we see whether the documents and procedures which has been made by the organization is maintaining those things or not. So audit is looking into the evaluation of the occupational and health and safety system. So the Bhopal disaster in 1984, it has changed the scenario of the health and safety system in Indian industries. That particular incident brought safety and health into once more into the focus, and there was a need. Government felt that there was a need to change the statutes and the enforcement procedure. So the mandate of safety audit came into force in this period after this accident. Before that, also audit was being carried out, but the particular health, safety, environmental audit was not that popular and not that important before the Bhopal accident. So after that, it started and rules were made after that. The rules which were changed after the Bhopal accident, I want to mention it, is that dissemination of information about the chemicals and its hazards to the workers and also to the outside organizations. So this is the most important thing about the changes and involvement of the workmen with the management, so that they also know the problems and its disadvantage, how to help them, how to carry out the work safely. The advantage of it, though the safety audit was initially made for industries, but other establishments later found that this has many advantages. So there are other organized establishments such as big tech parks, hospitals, large building complexes. They also started doing safety audit, and our organization has done many safety audits like that. Next slide, please. Oh, sorry, I can change. The basis of this paper is I have visited many large and medium scale power plants, machine and automobile assembly units, cement industries, chemical industries, petrochemical plants, steel plants, fertilizers, pesticides. There are a lot of echo. Can you stop the echo or other disturbances? Dye industry, soap manufacturing plants, service sectors such as tech parks, airport, hospital, high-rise apartments. So based on these audits and inspections, I have made this paper. Initially, I was in atomic energy, so I have inspected nuclear power plant construction sites, uranium mine and mills, and processing units related to nuclear power plants. Safety audit and safety inspection both strive for safer workplace, reduction of injuries or harm to the occupational health and safety. But the main difference between safety inspection and safety audit is that safety inspection looks at the hardware part of the establishment. That means whether there is any leakage, whether the machine guard is there or not, whereas the safety audit looks at the software aspect. That means your, for example, your um, uh, incident investigation system is working or not, whether your permit system is working or not properly as per your guidelines. So the safety audit looks into software aspect, whereas the safety inspection looks into hardware aspect. The safety audit looks into many things. Out of that, I have only listed few of the things, whether the involvement operating personnel are there, dissemination of information about hazard, which is the newly added clause in the Factories Act, so that the operating personnel and people who are nearby, they can understand the hazards and they can act accordingly. Then it looks into risk assessment. We will talk about that. It looks into safe operating procedure. It looks into training, health, and roles and responsibilities of safety and health in charges, permit to work system, accident near miss investigation, competency and assessment procedure. That means this is the training and with their capacity building procedures. Those are also seen by audit. Contractor recruitment and assessment procedure, and also prevalence of safety culture. There are so many other things. So that, so for example, that outside you have to have some 2% cost on the outside premises development, and there may be so many other things, but we are looking now, I am looking into only these few things. Over the years, there are improvement in the safety system overall. So those improvement I have listed like this. Nowadays, the housekeeping and cleanliness of industrial establishment is much better. Machine guardings are looked into much better way. Hand tools maintenance and maintenance records are quite systematic, which was not there. Manual handling being slowly replaced by automation in many industries. Management of contractors, their evaluation and feedback system on their performance is also much better. Nowadays, they are getting regular feedback from the management. How is their how is their performance? Whether they need to improve their performance, whether they need to have more personal protective equipment, whether they need to more automation. All these things nowadays there is a feedback system. Work permit system is quite systematic because we have in audit we scrutinize the work permits, that whatever is written there, whatever is at the site, whether these are matching, whether their risk analysis is telling some more precautions are to be taken. Those are all mentioned in the work permit system, and we have checked in most of the cases it is quite good. Use of PPEs is good because in 1986, when I started inspection initially in atomic energy units, also people were telling that using helmet is very difficult. But nowadays the situation is totally different. However, the use of chin strap and the small things that respiratory protective devices are not so systematic. There is a focus on health and exercise, etc., in the organizations, which is also a good sign. Sorry. The areas of improvement is more because in audits find the areas which can be improved. So the main purpose is that you must be knowing that risk assessment of activities are being carried out in industries nowadays, as well as in other establishments in the big tech parks and other things. Many activities are being assessed. So risk assessment is, it is giving in advance giving the in advance what are your hazards, how you have to give the precautions to be taken. So risk assessment is looking beyond the present scenario. So these are being carried out. It's a good thing that nowadays industries or establishments, they know the subject, that is what is risk assessment, they know, but the utilization is disproportionate. They take so much time for carrying out the risk assessment. This is, I am talking about the qualitative risk assessment, that is primarily as per IS 18001. Time and manpower are utilized, but these sheets, these assessments are not exactly streamlined. There is very less recommendation in the risk assessment, which is expected from the risk assessment studies. So mainly it remains as a paper. So recommendations are not mentioned, and the assessments are not reviewed by senior people. So need to utilize the use of the risk assessment. That is my our audit observation finds that it's good that people understand the risk assessment, but they should know that how to use it, and the people should be trained about it. Next, I want to tell about the quantitative risk assessment, which is primarily useful for chemical industries. See, it tells the effect distance, that in case of release of any gas or liquid, how it will affect at a particular distance. Yesterday, there was a paper from Dr. Das, who told that the styrene has gone up to a long way, and if the audit was there, it could have been found that the document is there which had been told. I'm not sure about it, but the document will tell everything. But the use of the document is not good. That management is not taking that much time. They feel that it is a document which is to be kept because it is a statutory requirement. So there is no need much to use time and subject. Moreover, the subject is also not a very well-known subject, or it is taught in a regular curriculum so that people can understand it. For example, at a distance of 12.5 kilometer per meter square, that is a manual exchanger. At 12.5 kilowatt per meter square, it can cause second degree burn within 10 seconds, because 125 kilojoule per meter square is giving a second degree burn. So if I put a manual extinguisher, a person will not be able to operate this. So this type of analysis is given in these documents, but management generally does not look into the document and change their positions. Sometimes it is difficult to change after a construction is made, but there can be ways to prevent those problems. But there is audit tells that this quantitative risk assessment documents remains as a only document. Very few use has been found in this audit, all the audits. Very few cases we find that really this is being used. So next is that next is that the chemical safety and dissemination of information. The concept of chemical safety is not much encouraged, because if you tell the workers that this particular chemical is very hazardous, so they will be scared to use it, and there may be a inhibition for working or not. But now our country is poor. No one will tell that I will not work, but there will be a fear of working. So it is not much encouraged. It is not universally true, but in most of the industries and in establishments also, we find that the chemical safety is not told much. And if you see their induction training, there are 20 subjects which are taught in maybe 3 hours. So it is not possible to understand all the subjects in this small time. So the competence and trainings are also important part of the safety audit, which we look into and find that really the training programs are useful and effective or not, that management may take more time to look into. For example, threshold limit value, TLV, it is mandatory to tell the TLV of the chemicals whenever there is a hazardous chemical. TLV is mentioned, but what is to be done with the TLV? What is the purpose of the TLV? Why I am displaying this one? Workers does not know really. And we know that it is an acceptable limit. However, we meet the alarm is set at TLV. The alarm like that. The alarm is not the TLV value. TLV is an acceptable value. It should not be exceeded. So you can keep the ventilation. TLV is mainly for the purpose of ventilation. It is not for the alarm or the release. So warning of the carcinogen component in the hair dye. Some hair dye factories we have visited, you will find that in hair dye, the carcinogen component is written in a very small letter. And our consumers don't understand. The workers also don't understand. We have seen that their hands are totally black, handling black dye color. Is not that evident. Okay. And next is that incident investigation. We know that incident investigation procedure is required for any incident or accident, but we have found that the incident investigation is not going to the root cause. Root cause means management action which can prevent further accidents, similar accidents. Though, so the revision or the investigation result can lead to revision of operating procedure, effectiveness of training, need and scope for automation. But you will find most of the time the blame is on the person who has undergone the accident. Position of safety in charge and section is also important, which we find that in many organizations, they are reporting to the production manager, the production system. So there is a conflict of interest between safety and safety and production. So it is better that reporting of the safety in charge should be the top management, not for at least for the production. The occupational health is now a little better, but we have found that routine checkup of the occupational health is being done. However, these are not analyzed. Test reports are not analyzed. Progressive deterioration or improvement on individual and prevalence of occupational diseases are not explored. You must be knowing that occupational diseases are such noise-induced hearing loss or silicosis or pneumoconiosis. These are irreversible. So if this happens, the person will have a permanent damage in his health system. Prevalence of musculoskeletal problems are not considered as occupational disease, though as per Indian statutory requirement, though this prevalence is now increasing and there is a need to look into it. So the occupational health is being, some tests are being done, but these are not being analyzed. So this is the brighter side of health checkup is that health campaign and counseling procedure practiced in many organizations, benefited with good diet charts and suggestions for exercise. These are good things. Workshops and discussions in the field of health and nutrition are also being conducted. Industries are enthusiastic about the healthiness of their operating personnel, arranging many tournaments and exercises. Even some industries even consider use of less oil in canteen food to prevent obesity, lower the body mass index. So the conclusion is that safety audit looks beyond the statutory requirement and towards a good safety culture. It has assessment, there is a need for assessment and utilization of the training. There is a need for comfortable workstation, good feedback between management and operating personnel, dissemination of information, better awareness about hazards and its mitigation. Thank you very much for giving me time. Any question?
Thank you, Sudhapati. So we'll take one question from the audience.
If there is any. Okay.
My name is K. Mark 1991. There was one simple question. Safety lapses in our country. Is it punishable offense?
I'm not able to hear what you are telling.
Safety lapses, various stages of manufacturing in plant product stage. There are gross safety lapses. Which is a punishable offense?
I am not able to hear the question. Can anyone who is near the mic can tell it? Ashim, can you please repeat the question?
My question is, can you hear me now?
Yes, sir. Now I can hear.
Okay. So at the various stages of manufacturing a product, say we start with the design, then we go for production and then maintenance and selling and after sales. In all those aspects, there are some safety components what we have addressed right now.
Yes.
If at any stage there is a lapse in safety, is it a punishable offense in our country like they have in Europe?
Not all are punishable. Some of the punishments are mentioned in the Factories Act, but all are not punishable. But in case of accident, there is a possibility that the owner or the occupier may be made the responsible. And incidences are there that sometimes they are prosecuted.
Thank you very much.
Thank you.
So it's time for the last presentation of this session to be given by Madhu Agrawal, investigating the surface properties of agro waste derived activated carbon and its versatile applications to treat Oh, okay. Oh, we heard you. Okay, so you are ready to give the presentation?
Hello,
Yes.
am I audible?
Yes, we can hear you very loud and clear.
Yeah. Actually, I don't know. My camera is not working. I don't know why.
For the time being, just go to your presentation and share the screen.
Okay. I'll do that.
And again, before you
प्रेजेंटेशन
finish,
में कैमरा नहीं चल रहा है.
after you start your presentation, I'll come back and show you the screens.
Enjoy. क्या प्रॉब्लम है इसमें? अभी थोड़ी देर पहले चल रहा था, पता नहीं क्या हुआ. करो एक बार.
Okay, share your screen, please.
शेयर स्क्रीन करो. चल कोई बात नहीं. स्क्रीन तो है.
Okay, you do not have to turn on your camera, just to go to the presentation. You see an upper arrow, click on it, and then bring up your presentation.
Madhu, go to presentation mode to share your slide.
हमारी स्क्रीन आ कर रहे हैं cannot share इसको
Go to
sir, sir, I'm trying but there is some issue with the laptop. Let me open in a desktop.
Okay. Start.
आ रहा है आ गया Are you able to see my screen? Are you able to see my screen?
Not yet.
Not yet. Share नहीं हुआ ना share करो उसको कोई नहीं ना तुम्हारा share विंडो में कोई हो रहा है share करो Is it visible? Is it visible?
No.
मैं इसमें बोलूँ जैसे यहाँ से बोलती हूँ मुझे देखो मेरा स्क्रीन कैसे शेयर होगा माइक कहाँ का यूज करूँ अरे किसी और का ले लो मैं टाइम लगाओगे अभी
লাঞ্চের পরে লাগবে তো লোকজন সব খুঁজে পেয়ে গেছে
স্যার কি প্রবলেম আছে আপনি ওটা হচ্ছে বুঝতে পারছি না
ওটা যদি প্রেজেন্ট করবে স্ক্রিনটা চলে যাবে আনপিন করে দেবে হ্যাঁ ওটা কি এখান থেকে ক্লিক করো হ্যাঁ সেটা আমাদের
Madhu, better you send me the PPT, okay?
Sir, I'm trying. Give me 2 minutes only. I'm trying. Just 2 minutes. अब तो आना क्या आ रहा है ना इसमें यहाँ से शेयर करो तो उसमें कैसे आ रहा है वहाँ दिखेगा ना तुम यहाँ से क्लिक कर देना उसको चेंज कर देना Is it coming?
Yes, it is coming. You go to the PPT.
now share your PPT
I'm doing, sir. नहीं है ना Is it visible, sir, now? Okay, okay, thank you. Yeah. Good afternoon, everyone. Myself, Dr. Madhu Agarwal. I'm here to present this work of mine, which has three categories. One is the investigation of surface properties. One surface properties of agro-based derived carbon and its application in water treatment, and third one is the novel technology which is now very common, is the capacitive deionization, use of capacitive deionization. So before starting my presentation, I want to say a few words about my institute where I'm working at present. So I'm working at National Institute of Technology, Jaipur, and it was previously known as Malve Regional Engineering College, but in 2002 it has been converted into National Institute of Technology, and then it has been given an Institute of National Importance status. The institute is extended in 300 acres. Campus is last green campus, and it has all the amenities for comfortable stay, that bank, post office, and all these things. So I welcome all of you to visit my institute. In our institute, there are the many engineering departments along with one management department. So here there is a chemical engineering, chemistry, civil engineering, computer science, electrical engineering, electronic communication, and all these things. And the research area in which we chemical engineers at chemical engineering departments are working is water and wastewater treatment, biofuels, membrane separation, heterogeneous catalysis, waste to resource generation, and all these things. So presently we are 25 faculty, so most of the area has been covered. Now come to the topic. So as we know that all chemical engineers know the importance of environment, and we I think that the person who know how pollution is important and why pollution has been created. So here in this category, I want to define what are the wastewater and wastewater we are dealing with to treat. So I have categorized it into 3-4 categories, that is domestic wastewater, industrial wastewater, agricultural wastewater, and other wastewater. So in domestic wastewater, you find that there is one term is written that is called RO reject. Now we people know that water treatment, because nowadays water treatment is very essential along with the wastewater treatment, because water scarcity is a very important point to be considered. But now why RO reject? Because we know that now RO is a technology which is adopted almost everywhere in India for getting clean drinking water, free from all kind of microbial and salt contamination. But the biggest drawback of RO is that it produces a huge quantity of reject water, which is need to be retreated. Otherwise, there is a huge loss of water, which in many area of India cannot be afforded. Because myself reside in Rajasthan, which is considered to be an arid region where water scarcity is one of the biggest problem, and this wastage of water is not affordable. So this has been kept in the category of the water which has to be treated under the domestic wastewater, because there are many domestic units are installed. Then there comes the municipal wastewater and sewage treatment. Then one of the important thing is that industrial wastewater. So in industrial wastewater, in this topic, I'm considering mostly the textile wastewater, because in Rajasthan and especially in Jaipur, many dyeing industries are small dyeing industries are available, and there is many zones where these industries are flourishing, and this when clothes are dyeing and designs are made with the help of different dyes and pigment, and the clothes are highly exported to the other countries also. So these industries are very much flourishing, but there is a biggest issue of water treatment, because the effluent which is generating has to be treated, otherwise there will be, as I've told you, that there is a scarcity of water. So this is very essential part which has to be taken care by the researcher. Then there are the agricultural wastewater nowadays we have to consider this also, because in agriculture, as we all know, that there are huge pesticides, herbicides are used, and these pesticides and herbicides are used in large quantity, because the optimum use of these pesticides and herbicides are not known still to the farmers. So they use in a large quantity, and when these pesticides herbicides goes along with the water, they creates a pollution. So these are the important stream which need to be addressed. Now, as I've told that what are the sources of RO reject, as I already specified, that RO are placed in every domestic household, as well as in Rajasthan, because of the high TDS of the groundwater. Because in Rajasthan, especially in many cities of Rajasthan, the surface water availability is very poor. So most of the population depends on the groundwater, and this groundwater has one of the biggest problem of high TDS. So high TDS, fluoride and nitrate. So it has been considered that the RO is the one of the solution. So the many community RO plant has been installed in the Rajasthan in order to cater the drinking water need of the community. So there is a huge RO reject water is generating, and this reject is again fed back into the ground. And because of this, what happens? The groundwater TDS goes on increasing. So this reject water has to be retreated by some means, so that the water can be saved. And textile dye, as I told you, that it is the biggest problem. Now, as we consider, if we do consider the scenario of wastewater discharge in India, then especially I have told you that there are many RO plants community RO plants has been installed, and in Rajasthan we have did a survey of 200 plants, and we found that a huge quantity of wastewater is generating, and that wastewater is fed back into the groundwater and increasing its TDS. Similarly, a huge quantity of dye stuff has been used for dyeing purpose, and the water is huge quantity of water is used, and the wastewater is released back into the ground. Released back into the ground, and as well as without treatment. So if you look at, there are 4 places written here. One is Pali, Palotra, Jodhpur, Sanganer, and Bagru. These are the places where dye industries are there, and now the Pollution Control Board has very strict about the treatment of the water. And also there is a planning of common effluent treatment plant, but still because of the different variety of nature of the dye stuff wastewater, this common effluent plant is still not feasible. So we come to know about that what are the pollutant, or what are their effect on the human health. So there are as you can see from this slide, that the dye wastewater, heavy wastewater, more salt, and food toxicity, all these are affecting through the ecosystem, through the food chain to the human being as well as animals. So we, being a researcher, we should consider to remove all these pollutants from the water and get good and healthy water for the human being as well as other components of the environment. So if you look at the traditional method which has been adopted to treat the wastewater stream or the water stream, if you say, these are mostly categorized into 3 categories: physical method, chemical method, and then potential waste method. In physical method, membrane filtration, as we know that nowadays RO is very common. Then previously it was ion exchange which was used, but because of chemical that salt requirement, this ion exchange is not that feasible. Then adsorption is one of the solution. Then chemical metal electrode advanced oxidation processes are very common, that ozonation and Fenton reagent and photochemical reactions. But these techniques still requires many chemicals, and these chemicals has to be handled properly. Now the potential based methods are coming forward, in which the deionization and electrolysis reversible is the one of the technique which is used to remove the pollutant as well as to treat more high TDS water. So in this presentation, I would like to focus on one of the technique that is called capacitive deionization, which is nowadays used for deionization of the water, because it is a focus type of technique where the electrical potential is applied between the electrode and which causes ions to migrate and get reduced at the surface of the electrode and get discharged on the electrode. So electrode material is important here. So as we know that we people are working on adsorption, so this technique is extended version of the adsorption, where we need a such type of material of the electrode which has high capacity to absorb the ions and retain the ions. So this capacitive deionization, then when a small voltage is applied, a current is passed, and ions are migrating toward cathode and anode. And if cathode and anode are sufficiently porous, made up of a porous material, the ions will get absorbed inside the pores and on the surface of the pores, and the water is free from ions. So this technique has been adopted to remove the high reduce the TDS of the water, as well as to remove the dye stuff from the water. So this is the concept of capacitive deionization. A small voltage is applied between the electrode, and ions get absorbed on the surface of the electrode. And as we know that cation moves toward cathode and anion moves toward anion, so when this movement is there is a formation of layers of the ions, and this process is completed when a complete stable double electrical double layer is formed. And then the discharge can be easily made by reversal of the charges of the electrode, or by utilization of a chemical such as HCl for regeneration of the electrodes. So this is a very effective technique, and it is because the potential requirement is low, the operating cost is low, and it gives a better or selective ion adsorption. So this technique has been explored in my lab for removal of salt from the water as well as dye from the water. So this is what is the motivation? Motivation is that motivation behind this study is that, as I've told you, that is RO reject, to treat the RO reject, because we don't want the water to be wasted, and then to check whether capacitive deionization technique is good for dye effluent also, and to check whether we can make a better material which has high porosity, high surface area for making the electrode. So this effort has been motivated. This effort has been required to do the research. So we have started this one. So now how we have gone ahead. So first as I told you that a good material is required for electrode. So mostly so we have selected the waste material. Because what happens if I'm making because most of the in this capacitive deionization technique, the carbon based electrodes are behaving better compared to any other material. So we thought that why to use the activated carbon which is available in the market, which is costly. So we have taken a waste material to convert it into activated carbon, and that waste material we have chosen which is of no use to any animals and any other category for the food. So we have selected the walnut shell has been selected because walnut is India is producing huge quantity of walnut, and nowadays people are consuming walnut at a very high rate because they have came to know that walnut has a good impact on brain health. So the consumption of walnut is also very high, but the shell which is left is of no use to the animal, because it cannot be fed to the animals because of its hard nature, and it's a hard and brittle nature. So it is of no use. So we have selected this shell to convert it into carbon. So we have collected the walnut shell, and then it has been washed properly and powdered, and then it has been converted into the carbon in the muffle furnace at appropriate conditions, and then it has been activated using the activating agent. So we have tried both activated agent, acid activation and alkali activation, and then we have used this material for preparation of the electrode. So this is how electrode has been prepared. We have taken the activated carbon, and then because some binders are required to make these particles binded together, so some binding agent has been added, and then this paste has been casted, and a square electrode were formed, casted, and they were formed for further use in the process. So once this material has been selected, so it has been characterized. As we know that BT is one of the important characteristics for surface area analysis, because whether the surface area is sufficient for ions to be held by the material. So we have did the BAT isotherm, and we found a good surface area of 268 meters square per gram. And isotherms are also very showing the nature of type 5 isotherm, which is a good that the variety of the pores has been developed, and this variety of the pores are suitable for absorption of ions. If you look at the same ideas, because the topic is to characterization of the material which has been developed, so we have did the same also, same ideas also, and if you can see that the same image shows a highly porous nature of the carbon which has been developed, so that's why the surface area is good enough. And EDS also said that is a mostly carbon, then small amount of nitrogen and oxygens are present, so there are the functional groups which are present on the surface of electrode, also helps in absorption of the ions. We have did FTIR analysis also, and this FTIR analysis clearly shows that there is a some kind of functional group carbonyl and acid functional groups are present on the surface of the.
Madhu, you have only 5 minutes, please.
Okay, I'll finish fast.
No, not speaking fast is not enough. We have only 5 minutes, then people would have to go to lunch.
Okay, sir, I'll finish. Don't worry. Okay, so this is XRD, and these are the characterization we have done, and we found that it is good material for electrode. Next. So these are the XPS characterization, which shows that both C double bond CO functional groups are present on the material. Now this is the important thing, that the electrochemical aspect, whether it can be a good electrode or not, whether it has a good capacity to absorb the ions. So because the capacitance is an important factor for capacitive deionization. So if you look at the cyclic voltammeter results, we found that a good rectangular shape is obtained, and at a small scan rate, the specific capacitance is good enough, that is 58.23, which clearly shows that it is a good material for to be used as an electrode material. And if we look at the Nyquist plot or electrochemical impedance study, we found that the resistance provided by the material is not much, so it is only 5.67 ohms, so which is suitable for absorption of ions by capacitive method. So this is experimental setup. This is the batch experimental setup I am showing here, but we have worked on continuous experimental setup also, and we found that the good results are obtaining. So electrodes were arranged and DC current is applied, and the samples were taken with respect to time to analyze how much ions has been removed. So this study is optimization study in initial concentration of electroabsorption time and percentage desalination. So percentage desalination is increasing in time, and at a particular after 70 minutes the charging is complete, that is no more absorption is possible. So now the electrode has been discharged and new charging operation has been started, and initial concentration the percentage desalination is decreasing with increasing the initial concentration, but the amount absorbed and the water which has been obtained after the absorption is of in the permissible limit of TDS. And this is how absorption capacities varies of the material with respect to time and initial concentration.
Madhu, can you please go to your conclusion slide?
Now, the possible mechanism is that the migration of ions.
Madhu, can you please go to your conclusion slide?
Okay, so we have done the same results with dyes also, and we found out the kinetics and isotherm of that one. After this, my conclusion. So summary is that the synthesis of electron may resulted in efficient desalination performance, and the maximum capacity for ion absorption is 22.98 milligram per gram, and for dye it is a very good, it is 140.8 milligram per gram, and the mechanism was found to be electrostatic force which are responsible for migration of ions. Thank you.
Okay, thank you, Madhu. Very nice. Thank you.
Thank you.
Okay, we have one question. Really, yes, hold on. There is one question from the audience. Really, yes, question. Okay, there is no question. So we all have to thank you. Okay, so some part of the process is now we have to
close the session, and let me invite whom? Oh, Devasis Bhattacharya, please come to the stage. Is he here? Oh, here. And since you were going to be presented, Devasis Bhattacharya. Okay.
Now we have to related to our product, but somewhere has not been done. So today, one presentation is here. Is not present here today. So I would like to request Professor Satyendra to handle the counter. He is from the hospital. Thank you. Another is Dr. Tafsir. He was also from ISCL, but he is not present here, so I would like to request some short help to college on behalf of Dr. Vera. Vishwanath. And by the way, Vishwanath is also our alumni. Dr. Vera, as well as the office of Dr. Vera. And I think this one is also working okay, so we are very necessary due to some technical difficulties. So we were supposed to be there and we will be. So we will be there to practice. So now packets are there outside the auditorium. So please go there and or target will be there to be. Thank you.